Hello friends, welcome to our Python signal handling tutorial. In this tutorial, we will learn how to capture and handle operating system signals, such as the SIGINT, which is produced by the CTRL C combination, and SIGBREAK, which is produced by CTRL plus break combination. We'll be using Python 3 to capture and handle those signals. This video is intended for somebody who is familiar with Python but doesn't know what a signal is. So we will start from the beginning. So we will learn what are signals and what is their significance. Second, we will learn about the signal module in Python, which is a module present in the Python standard library. You don't have to install it. It's already available. And this module is used to capture and handle operating system signals. Then in the third section, we will learn to identify which signals are available on which systems. For example, in Linux systems, there are a lot of signals which are not available in Windows systems. So we can use this particular function to identify which one is where. And in the fourth section, we will learn how to write code which will catch the operating system signals and then give it to a handler function which will do what you want to do with your code. And in the fifth section, we will learn to catch the SIGINT signal, which is produced by the CTRL C combination of the keyboard. And this is the one we will be concentrating more on because we will learn how to exit from an infinite loop. For example, a program that is continuously reading from a particular port, for example, serial port, in the form of an infinite loop. To exit from that particular loop, we will be using the SIGINT signal. And finally, we will use this code to develop a Python data logging system, which will log data, for example, temperature, pressure, etc., from the PC serial port. Now on the right side, you can see our data logging system. It's a 4-channel data logging system, which is based on Arduino and the serial port system, like here. And we'll be using Python code on the PC side. I will do a separate video. In this video, we will only be concentrating only on the signal sections. So to get to know when we are uploading this particular video, please like, share, and subscribe. Now we'll go to our signal sections. We have a website in which you can find the textual description of the video. And I will provide the link to the website in the description. So do check out if you want to see this one. And you can also find out the code. The code is available on GitHub. And I will show you here. This is our GitHub repo. From this, you can download the code. Now, the link to the code will be in the description of the video. So do check it out. And if you are in the GitHub section, do give us a star or fork it. And also don't forget to give us a like if you like our video. Now here we will tell you what are operating system signals. When a particular event occurs inside a PC, for example, somebody presses a CTRL C button on the keyboard like this, then the operating system will generate a particular event, which is called a signal. In this case, when you press the CTRL C combination, operating system, both Windows and Linux, will generate the SIGINT signal, which is then used by our Python script. And we will use that to perform certain actions. I have not written any particular handle code on receiving the SIGINT signal. The Python script will terminate. Now the signals all the signals in the system are given a particular integer number. And we will be using the Python signal library to access and use the signals. Now here we will learn how to identify the signals which are available in one particular operating system. On the left side, you can see the Windows system. And when we run the program, we will see that only 7 signals are available. And on the right side, you can see an Ubuntu system, a Linux system, in which you can get almost 62 signals. Now we will be using the signal.valid_signals function to get this particular, to get the number of signals available in the particular system. This function will return a set, which are then displayed on the terminal. Now we will check how to do that. I'm assuming that you have the Python interpreter installed. I'm using the Python 10 version. So now we'll write the code to do this particular thing. I've downloaded the code from our GitHub repo and I have installed Python. I'll be using Python 3.10. Now, first thing we will do is to check the available signals in our system. For that, we will be using this code, Python available signals.py, and I will be using the ideal ID, which is the standard one. So I'm going to edit it. The first thing we are going to do is to import the signal, this one. Here we are importing the signal module, which is used for handling the signals from the operating system. Second one I'm using is the platform, which is used to identify the operating system, because this particular code is cross-platform and it will run on both Windows and Linux. So this will help us to check which operating system we are running on. And the third one is called as the pprint or the pretty print, which is used to format the data structures. Now we will be using this particular function, signal.valid_signals. This will check the system for available signals, available operating system signals, and will return a set, which is then given to this particular variable, valid_signals. Now the other thing is that the platform.platform. This is used to identify or to print out which platform our script is running. If it is Windows, it will show it is a Windows platform. If it is a Linux system, it will show it's a Linux system. Now we are using the len function, the standard len function, to identify the number of valid signals. So basically we are measuring the length of the set here. Then we will use the pretty print or the normal print function. You can also use it to display the valid signals. Now I'm going to run this particular code and I'm on a Windows system. So we'll press the run module. So it is showing that operating system is Windows 10 and the number of available signals is 7. And I told you that each signal contains is assigned a particular integer. From here you can see that the SIGINT is assigned the number 2 and the other one is like that, 4, 8, 11, 15, etc. You can also find the SIGBREAK here. We will be concentrating mostly on the SIGINT signal and the SIGBREAK signal. Now I will run this particular code on Linux system. I have downloaded the code onto a Linux system. This is Ubuntu. And I am going to run the Python available signals.py on an Ubuntu system. So it will be Python 3, Python available -signals.py. So this will list all the available signals in an Ubuntu system. Now it's showing that operating system is Linux and the number of available signals is 62. As you can see that SIGINT is here and you can also see other signals like this. Some warnings. Sometimes IDs like Tony or idle may interfere with the capture of signals like SIGINT. If you are having trouble receiving signals, try running the code directly on command line. Like this one, C, Python, the name of the interpreter, and then your code directly. Then there won't be any issue. So just in case. Now you have seen the various signals in the Windows and Linux system. We are going to write a basic signal handling code. For that, we have to import the signal library, which is part of the Python standard library. Now, to write the signal handling code, you have to write two things. First is the signal handling function, and the other one is to register the signal with the handling function. So this is basically a pseudocode. And first thing we are going to do is to write the signal handling function. A signal handling function is similar to a normal function. You can write it by def, give it a name. For example, my signal handling function or signal handler for SIGINT, anything you want, you can write it. Then you have to give two variables, signal underscore number and frame. So whenever a particular signal that is registered with your signal handling function is called, this code will run, the code to do something. Now, the second thing we have to do is to register the signal. For that, we will be using a particular function called signal.signal. And it will ask for two parameters. First one is called as the name of the signal, which signal you want to handle. And the other one would be the name of your handling function. So my handling function's name is your custom signal handler. So you have to give the same name here. And for signal name, I have just given a generic name. You can either give signal.SIGINT or signal.SIGBREAK. If you're using signal.SIGINT, it will capture the SIGINT signal, which is produced when you press the CTRL C combination on a keyboard. Now we will go to the code. Now we will be using Python signal-sigint.py. You can open it in idle, edit with idle. So as usual, you have to import the signal, and we also need to import the time function. Now, here we are going to create a signal handler for SIGINT. Okay. So first we write the function def, and I'm going to name it as signal handler underscore SIGINT. You can give it any name, but here I will be using this particular one. Then I will be putting two parameters, signal number and frame. And this function will not do anything. It will just print that signal handler has been called, and then it will print the signal number and the frame. That is what the handling function is going to do. And now you have to register this particular handling function to the signal. For that, we will use the signal.signal function, and we are going to use the SIGINT signal. So signal.SIGINT. These are actually inside the signal library. So you have to use this particular name itself. Then you have to give the name of your handling function. Here it will be signal handler underscore SIGINT. Now at this point, the signal will be registered with the handler. Now we will be running a while loop. This is an infinite loop. It will constantly print Ctrl plus C and wait for 1 second. That's why we are using the time function. Now I'll run this thing. So now if I press Ctrl plus C, the signal handler of signal.SIGINT has been called here. Okay. And after that, the loop will print the signal number will be 2, and the frame will be this line. Now after the signal handler has been called, it will return back to the while loop and will continuously print this thing. If I press it again, it will whenever you press it, it will come back to the handler and will display it like this. So this is a safe way to exit from a infinite loop. Now I'm going to give an example of where we are going to use this particular function. Okay. So I'll close this thing. Now I'm going to run this particular code. Now this file does not do anything. It simulates a serial data acquisition system. Okay. So I'll run this code. It will continuously use a while loop and continuously read from a serial port. I mean, here we will not be reading anything. We'll just simulate it. We'll print that data. Okay. So I'll run it. So you can see that here we are saying that this thing is opening a serial port connection, and we are using an open file. I mean, opening a file and opening a database connection. After that, we are constantly reading from the serial port and writing data to database. So now we want to exit from this particular script. We can press CTRL plus C to exit from this particular script. And I'm going to do that. Now we have exited from the particular script. Now the issue is that all the connections that we have opened here, we have opened a serial port connection and opened a file connection and opened a database connection. All these things are still open and in an undetermined state. So we'll be using a signal, SIGINT, to capture that particular SIGINT, and then we will use that signal to close this function before the script stops. Now we will learn how to exit from an infinite loop properly using a SIGINT signal. For that, we will be using the Python signal infinite loop.py. We'll edit it with idle, and now the code is similar to the previous one. Here we are using a sentry variable to control the while loop. So sentry is a type of Boolean variable which we declare it as true when we first run the script. After that, we create a signal handler for the SIGINT signal, and then we register the signal with the signal handler here. Then instead of using while true, we will be using while sentry. So whenever sentry equal to true, the loop will keep on running. So during this particular section, it will be reading from the serial port and updating to the database, and everything will be done here. And it will sleep for 1 second. After that, it will keep on going inside the loop like this. Now, when we press the Control C, the operating system will generate a SIGINT signal, which will cause the control of the program to go to this particular section. Here, we will say that the global sentry is equal to false. You have to set the sentry as global because it is inside the function. Then the control will go back to the while loop, and while will check whether sentry is true or not. Here we are making it false, so it will make the while loop will fail. And then the control will jump to print. And here you can do the cleanup code. Here you can close the connection to the database and close the file and exit cleanly. This is how you get out of the while loop, an infinite while loop, using a SIGINT signal. So I'll run this code. So here we are in the while loop. We are constantly reading it from the sensor. Or now I am going to press the Control C. Sometimes IDEs may interfere with the capture of the SIGINT signal when developing code. So I would recommend you develop the code in command line. I was using idle. There were some issues that idle was interfering with the capture of the signal. So I'm going to run it on the command line CMD directly. For that, you have to type in Python, for the Python interpreter, and Python signal infinite loop.py. This will be the one that will be running right now, and I'll press enter. So as you can see that the system is continuously reading from the while loop. Now if I press Control C, You can see that the signal handler for signal.SIGINT has come. Now here the Boolean value of the sentry is true. So this thing is continuously reading from the while loop. Now if I press CTRL C, the code will jump to the signal handler, this one. And here we will turn the sentry to false. So after here the while loop will fail and the code will jump into this particular section. Here you can write the code to clean up the, whatever you are open, like files, file connections, database connection, and things like that. Here you can do that. I'll try it on Linux also. One more signal I have to talk is called as the SIGBREAK signal. SIGBREAK signal is generated when you press the Ctrl plus break combination on your keyboard. I am using a laptop which does not have a break key, so I cannot demonstrate it, but the code is there and I have checked it out with a standard keyboard. Now the code is very similar. We are just changing the signal name right here. Instead of signal.SIGINT, I am using signal.SIGBREAK. So if you press Ctrl plus break button on your keyboard, this particular signal handler will trigger and you can do whatever you want here. So that is one more thing. I hope you have a basic understanding of how to use the signals, especially the signals SIGINT and SIGBREAK for your particular Python programs. And in the next video, we will develop a program, a Python program, which will use these particular signals to log data from temperature sensors, like these 4-channel temperature sensors from here. And then we will log the data into a PC and into a comma separated variable file. So if you're interested, you can check it out. And to notify you, I would ask you to subscribe to my channel. If you like this video, do like it. And all the relevant links to the website, our code, etc. are on the description. So I hope you liked our video. Thank you.